Hi, I'm Olivia Vladica, and today I'm going to be presenting my arc length project, which was used to find the distance around a shape that I made in an area in Bergen County, in order to demonstrate things that I learned in calculus this year. So the path that I'm going to draw is seen right here on the screen. It is the Saddle River County Park. This area I used to play softball in when I was younger, so I'm pretty familiar with it. And this is basically meant to be a running path, or it isn't always paved, so biking wouldn't really be that advantageous. So I traced out the line using the feature on Google Maps, and I basically allowed a straight line along the side right here, which is parallel to Howard Drive, which will serve as my y-axis, and then my x-axis, which is parallel to the Saddle River pathway, which is right down here. The picture in this screen is a little bit shifted just due to the angle at which I had to take the screenshot, but it's relatively parallel. So this is just closer up. It shows that the y-axis is on the left side of the path while the x-axis is along the bottom. And it also shows 5 points that I plotted on this new so-called graph. So up here we have 0 on the x-axis, but it's 214 feet ahead. So that would be 214 on the y-axis. Here we have 59 feet into the x-axis and above 179. Here at what looks like a relative minimum, it's about 200 in from the origin and 118 above. Here it's at 351 towards the right of the origin and about 206 units above. It's all in feet, by the way. And at this endpoint, we have the complete x-axis measurement of 428 and a height of 232. So here I created, using the Desmos calculator, just a table of values from that, which I used to plot my regression. So we could see here the first point is at 0, 214, and the last is at 248, 232. And here are the intermediate points that we just talked about. So at first, Desmos suggested that I try a quadratic model. However, it didn't truly capture the shape. You could see that it does tend to look more cubic. So this is the first example of an equation that I got when I attempted a regression, but it's not quite accurate. I later moved on to the cubic regression that was negative, and what I got was a lot more accurate. You can see here I placed in all of the values and then put my sample regression equation, which is just a simple cubic equation. And it created a relatively accurate model, considering that the path is not perfectly smooth. There are a lot of jagged edges in the way I had to draw it. And it also gives me the parameters that'll be used in my equation. So here's just my path kind of lined up against the regression. As you can see, it's fairly accurate. It's just a more smoothed out version of what I actually ended up drawing. So because of the numbers I received from the Desmos calculation for the regression, this is the formula I got for our function. The function is negative 4.03 times 10 to the negative 6th power times x cubed plus 4.889 times 10 to the negative 3rd times x squared minus 1.250x plus 221.607. So that's going to be our regression equation throughout the problem. So next, we have our derivative, and so the derivative was found using the traditional method. Here we have our first equation, and here we have the derivative. As you can see, we're losing the constant, and we're scaling down all of the factors of x. And again, this will be used in our arc length formula. So here's the formula for arc length. It is basically a definite integral involving the square root of 1 plus the derivative squared. And when you place these values in, it looks a little something like this, starting at 0 and ending at 428 feet, because that's the distance we're covering. And when you put it all together, you get this kind of messy looking equation. However, you do get a nice clean number of 487.706. So that would be the length of the curved part of the path. And finally, you put it all together, and to get the final distance of my path, you get side plus base plus the arc length is going to give us our total distance. So that is the first side, which is the y-axis in this case, 214. The side all the way to the right, which is 232 feet, the base connecting the two, which is 428 feet, and the newly calculated arc length, which is 487.706 feet. So this gives us a grand total of 1,361.706 feet. Thank you.